Up to now, we've been talking only about image pixel dimensions, which determines the appearance of individual images. Now I'm focused on the pixel dimensions of displays. Pixel dimensions are often referred to as resolution. In fact, the term resolution can mean either pixel dimensions or pixel density. As I've mentioned before, I use the term resolution to refer to both. The more precise way to think about resolution is to divide the concept into pixel dimensions and pixel density. Display pixel dimensions are not the same as image pixel dimensions, as we've just noted. It's not the same as or 100% dependent on the physical size of the display. And it's not the same as the display pixel density, just like image pixel dimensions are not the same as image pixel density. Whereas image pixels have no inherent physical size, displays do have fixed dots on their screen that cannot be changed. However, those screen dots can form pixels of varying sizes. So in that sense, display pixels are like image pixels. They are both non-physical entities, with the difference that display pixels cannot be any smaller than the fixed dots on the screen. Image pixels do not have such a lower limit. There are two types of display pixel dimensions, both of which I've just alluded to. Physical or native pixel dimensions are the number of dots built into the screen. Their dimensions are a fixed number that cannot be changed, because these pixels are manufactured into the screen of the device. These dimensions are defined and measured by number of pixels wide by number of pixels high, just like with image pixel dimensions. Remember that each physical pixel on a display is always composed of 3 dots, red, green, and blue. These dots are of a fixed physical size, which makes the physical pixels a fixed physical size. Virtual display pixel dimensions is a setting in your system software that tells the display hardware how many of its physical pixels should be used to form virtual pixels that fill the dimensions of the screen. You're asking your display basically to simulate a smaller or larger display using less or more of its physical pixels. To do this, it has to combine its physical pixels together into groupings to form the larger appearing display pixels. This allows users who have poor eyesight, for instance, to decrease the display pixel dimensions to enlarge everything on their screen, which makes text bigger, thus easier to read, or increase the pixel dimensions to show more of the screen space, including windows, dialog boxes, etc. For instance, the display I'm using right now on my iMac is set to 2560 by 1440. Here's a visual illustration of the concepts of pixel dimensions, pixel density, and physical size, and how they relate to display or printer dots. Let's say an image has pixel dimensions of 144 by 144 pixels at 72 pixels per inch, with a physical size of 2 by 2 inches. Each pixel is composed of multiple display or printer dots, since those dots are much smaller than the large 72 pixels per inch that you can see magnified in the image. Now we're moving to higher pixel dimensions, but keeping the 2 by 2 inch physical size the same. So the pixel density has to be higher. You can see the smaller size of the pixels. Finally, we have much higher pixel dimensions at the same physical size. So now each pixel is composed of a single display or printer dot. Here's an example of where we're changing the physical size, but keeping the pixel dimensions the same. So here we're going up from 2 inches by 2 inches, then to 4 by 4, and then 5 by 5, but we're keeping the 800 by 800 pixel dimensions. Now the display or printer dots need to accumulate into larger and larger groups to form these bigger pixels. Typical options for display pixel dimensions depend not only on the physical resolution, but on the physical size of the display. The bigger the display, the more potential pixels you can have at your disposal to increase the pixel dimensions set in the display resolution settings. Typical modern display sizes vary widely by device, of course, but for desktop computers, they are commonly what you see here, from 21.5 inches up to 32 inches. This measurement is the diagonal from one corner of the screen to the opposite corner. The following are the display resolution settings that you should be designing and testing on. I showed examples of these settings in the Screen Real Estate section of the Layout unit. 1920 by 1080, which is Full HD, it's becoming a standard for most displays. 2560 by 1440, which is known as QHD, popular in higher-end monitors. And 3840 by 2160, which is known as 4K. It's increasingly common for high-definition tasks. The best practices related to display pixel dimensions are the following. 16:9 is the aspect ratio that's optimized for video playback. It's the most common aspect ratio, that's width to length, for displays nowadays. This is what you need to use for anything you intend to fill the screen. Focus on pixel dimensions rather than pixel density for web images. All images used to be set to 72 dots per inch by default because that was the pixel density of most displays. But that's obsolete now that there are so many displays out there with different pixel densities. Pixel dimensions are what is critical now for graphic artists. The ideal is to map one physical pixel to one display pixel. The native pixel density provides the best display clarity and sharpness because it matches the physical pixels on the screen. Using the display at its native resolution ensures that each pixel data from the input source directly corresponds to one pixel on the display, which is the best image quality. Here is a skills application challenge. In the system settings of your computer, find where you control the display pixel dimensions. Play around for a while until you're comfortable changing these settings, then go to the next video.